was headed for Proxima Centauri, it would take 70,000 years to get there. And that's only the nearest star out of the hundreds of billions in our galaxy alone. So if we want to endure as a species beyond the projected shelf life of our own planet, we'd better act like the Polynesians. We need to take what we know of nature and build sailing ships that can ride the light as they once rode the wind. These sails are enormous, miles high, but they're very thin, 1,000 times thinner than a garbage bag. When a photon of light strikes those magnificent sails, it gives them a little push. This means that in the vacuum of space, even the tiniest push from a photon will propel them ever faster until they're moving at a significant fraction of the speed of light. When you get too far from your star and the light dwindles, lasers can do the trick. If we were to light sail our way to Proxima Centauri, it wouldn't take 70,000 years, but only 20 years. Proxima b lies in the habitable zone of its star, but we don't yet know if it could support life. Does it have the kind of protective magnetic field that has sheltered the evolution of life on the surface of our world? Another consequence of Proxima b's close location to its star is that the planet is probably tidally locked. One side perpetually facing the star, the other doomed to endless night. These little stars may be lukewarm, but they have a long future ahead of them. Trillions of years. Think of the continuity and growth potential of a civilization with a future measured in trillions of years. It's always magic hour on the strip of land that lies between day and night on this world. If Proxima b is habitable, its life would be confined to this twilight zone. It could be a home for the indigenous life here, or a possible campsite for our descendants. The gravity on Proxima b is about 10% greater than ours on Earth. No real problem for us. Just a little like exercising with weights on. Remote scanning from orbit found no apparent signs of life, making Proxima b a way station on a much grander interstellar diaspora of Earthlings. But for those longer trips, we're gonna need a faster boat. Let's say we found a system located 100 light years from home, one with several potentially habitable worlds. For light sailors, that would be a 500-year-long trip. Is it possible to build a ship that could break the cosmic speed limit? A mathematical physicist, Miguel Alcubierre of Mexico, inspired by the original Star Trek television series, conceived the calculations for a ship that could theoretically travel faster than the speed of light. If successful, it could cut the travel time between our sun and this distant star system down to a single year, or even less. But wait a minute. Isn't it a cardinal rule of science that thou shalt not travel faster than light? It is. But here's the thing about the Alcubierre Drive. It doesn't move. The cosmos does. The ship itself would be enclosed in its own space-time bubble, where it needn't violate any laws of physics. Harold White of the United States ironed out some of the kinks, such as prohibitively enormous energy requirements to fly it. But it remains far beyond our immediate grasp.
Look how fast that
The
is.
Alcubierre Drive ship is
Right?
a gravitational wave-making machine that compresses the ocean of space-time in front of it and expands that ocean in its wake. Jet skis for joyriding through the galaxy and beyond. Who knows? Maybe the entire Laniakea supercluster could one day become our pond. That's 100,000 galaxies.
Oh, Lord.
Laniakea, the phrase in Hawaiian for immeasurable heaven.
Look more than the vacuum.
Alcubierre Drive could do 600 trillion miles in the blink of an eye.
Right.
Before you know it, you're in the planetary system of a distant star. Let's call it the Hoku system, a red dwarf star surrounded by a retinue of rocky and ice giant planets. Somewhere among them is a world that we have come to call home. Our cosmic telescope sifted through all the stars within a radius of 100 light years and pointed the way to this one.
26.
All 7 of these planets huddle closer to their star than Mercury does to our sun.
32.
Haumea is just on the outskirts of Hoku's habitable zone. Those warm green colors seem inviting, but we're not seeing the tops of forests. That green comes from methane and ammonia. Even at a distance of only 27 million miles, the star Hoku is too weak to keep this planet warm. We are now in the sweet spot of Hoku's habitable zone. And this is the planet Tangaroa, where the latest chapter in the saga of our species is playing out. It took a few hundred years for humans to terraform this lifeless world. But now, even the air tastes as sweet as home.
Okay.
But this was only Indonesia, one of the earlier stops on our nomadic odyssey throughout the Milky Way. There were still so many islands that
Who's
lay
calling
ahead.
me?
And in this dream future of
You're not
ours,
saying
with our
anything, though.
faster-than-light craft, there would come a time when we could place our cosmic telescope far enough away from our home planet to see firsthand those of our nameless ancestors who
Right.
first set sail on unknown seas.
Right.
It's my 912, no days off, migraine medicine. It's Ubrelvy for...
Okay. Which way should you be?